Today, we're going to dive into the fascinating world of celestial bodies, starting with the Moon. The Moon is the natural satellite of Earth, orbiting our planet at an average distance of around 384,400 kilometers. It's the fifth largest moon in the solar system, and it's the only natural satellite that humans have landed on. The Moon is about 1/4 the size of Earth, but it's not round like a ball. Instead, it's an irregularly shaped body with a diameter of about 3,474 kilometers. The Moon is made up of rock and metal, and it has a thin atmosphere composed of gases like oxygen, argon, and sodium. The Moon's surface is covered in craters, which are the result of impacts from asteroids and other space debris. The most prominent feature on the Moon is the Sea of Tranquility, where the Apollo 11 mission landed in 1969. Hey there, space enthusiasts! Today, we're going to explore the exciting possibility of traveling to the Moon.
The ground begins to tremble.
3,
Massive engines roar to life.
2,
Billowing clouds of exhaust.
liftoff. We have a liftoff.
A mighty Voyager explore the vast universe.
Imagine this, you're standing on the lunar surface, gazing up at the Earth, and feeling the thrill of being one of the first humans to set foot on the Moon since the Apollo missions. The journey to the Moon is a thrilling adventure filled with the wonder of space exploration. But let's not forget the challenges that come with such a trip. You'll need to be prepared for the harsh environment, with temperatures that can range from -150 degrees Celsius to 120 degrees Celsius. You'll also need to have a rock-solid plan for the journey back to Earth. So, while traveling to the Moon might be a dream for many, it's important to remember the incredible challenges that come with such an adventure.
The Moon orbits our planet at an average distance of 30 Earths. It rotates at the same rate that it revolves. So as it revolves around our planet, the same side of the Moon faces the Earth at all times. From the Earth's surface, we can observe 8 distinct, traditionally recognized stages of the Moon's illumination. Called lunar phases, they have been observed for thousands of years and even provided the basis for the earliest calendars.
aka Science City in Japan. 2 completely different companies are on a mission to see if they can separate moon water into hydrogen and oxygen on the lunar surface. Not just a dream, the countdown is on.
It's taken Takasago Thermal Engineering 4 years to dream up this device, a mini electrolyzer strong enough to survive a trip to the Moon. Adapting the knowledge for extreme conditions in space has been a labor of love, one spearheaded by Takasago engineer Atsushi Kato. He gave me exclusive access to the lab where the company does fundamental hydrogen research.
Electrolyzer use very basic electrochemical reaction. When we supply electricity and water to a reactor called cell, the water split it into hydrogen and oxygen.
But you're doing this in space, on the Moon. That's where it makes it difficult, right?
The most difficult point is adaptation for the low gravity, because for water electrolyzer, gravity is very important factor. But on the Moon, gravity is 1/6 compared to that of Earth.
Another challenge, the intense vibrations during liftoff to space. If the electrolyzer stays intact after the lunar landing, it'll run on energy from the sun that's available for about 10 moon hours a day. That's about 2 weeks in Earth time. Operated remotely, the device will first attempt to make hydrogen from Earth water.
How much water are you bringing?
A few hundred milliliters.
And how much hydrogen are you planning to make? If everything goes perfectly.
It's a small amount compared to Earth use.
For the past 100 years, Takasago's ducts and ventilation systems have snaked through the walls of Japan's most iconic buildings. More than 700 patents later, it now bets green hydrogen will propel the company forward. Hiroyuki Muraoka is Takasago's executive officer.
We started to study hydrogen almost 20 years ago, and now we are developing large-scale electrolysis laser, and what we do in space would give us definite technology and skills to bring more efficient and easy to operate the machine that would differentiate from the competitors.
I need to be realistic. The electrolyzer is tiny.
Yes.
And to be able to do what you're talking about requires scale.
This is an experimental mission. Once we obtain the data, then we start thinking not only by ourselves, with the companies who have interest to doing the business with us.
To get to the moon, Takasago is hitching a ride with a company called iSpace, which joined the world's dash to the moon 11 years ago. As an early investor, Takasago has secured a seat on iSpace's upcoming second attempt to put a lunar lander on the moon. The lander is due to launch in a SpaceX rocket in the fourth quarter of 2024. For more on the company's vision, I caught up with Chief Technology Officer 𝐒𝐡𝐤𝐢𝐬𝐬.
We just completed final system environmental tests. All payloads are also ready for launch. We carefully selected our landing site to avoid a similar issue in the mission too. And of course, we also improved our software too.
Can you just tell me a little bit about the physical features of the lander?
The size of lander is more than 2 meters. At the bottom of the lander, we have in total 7 propulsion thrusters. The mass is around 1 ton. But surprisingly, almost 70% of the mass is occupied by propellant. Because in order to make a soft landing, we need to spend a lot of energy to cancel lunar gravity effect and so on.
I'm interested when you say 70% of the mass is propellant, because here we are talking about potentially electrolysis on the moon. And if you can do that, you can make enough hydrogen eventually to maybe fuel these missions so that you don't have to carry so much propellant. Is that the goal or the dream that we're talking about?
Yeah, of course, not only our space, but also the other players, interested in lunar water resource. That hydrogen, oxygen can be like a propellant for spacecraft. If we make a moon gas station, we can fly far away like a Mars and so on.
When it comes to space exploration, Japan touts a public/private sector approach, unlike in other countries that rely heavily on the wealthy. Earlier this year, the Japanese government launched a $6 billion plus fund to boost private space ventures. Rounds of similar initiatives have given newcomers like iSpace the capital to grow.
And liftoff.
I spoke with the physicist Hitoshi Murayama about the experiment's viability.
The biggest question is how easy it is to get water on a lunar surface, so that people believe that it's actually hidden in the soil, but you need to actually take that out and separate that for the rest of the junk you don't need, and so that's the hard part. But once that's done, then the splitting water into hydrogen and oxygen is a well understood technique.
How realistic do you think doing something like this is on the moon?
It's possible in principle because you can do it yourself. So the only question is how efficient the process is. And right now, relying on the power alone, you do need to actually put a lot of power to actually do that.
A lot of buts and ifs. Getting there, digging, scaling up on another body to make enough hydrogen for fuel. But for now, the pursuit is and will keep us all dreaming big.
Thank you for joining us on this cosmic journey. If you enjoyed this video, please give it a thumbs up, and don't forget to follow and subscribe for more space-related content. Until next time, keep exploring.